Hey guys, I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have defined the term of fuel cell and we have seen some of the fuel cell as well, such as hydrogen oxygen fuel cell and ion exchange membrane type of fuel cell. Now in this video, we will mainly focus on fossil fuel such as molten carbonate fuel cell, and we will see some of the advantages and disadvantages of this fuel cell as well, and we will conclude this chapter with different type of electrodes. So let's get started. Well, one typical molten carbonate fuel cell utilizes the molten carbonate as its electrolyte, which is positioned between two electrodes which are being made up of nickel material. This type of fuel cell is known as high temperature operating fuel cell. Since they operate at very high temperature, they do not need any kind of catalyst. The hydrogen can be supplied from different hydrocarbons such as methane and kerosene. The oxygen is supplied from air. Now let's see how one typical molten carbonate fuel cell works. The hydrogen and carbon monoxide mixture is supplied to negative electrode, which is anode compartment. Now here in this image you can see that the hydrogen and carbon monoxide is being fed to anode section where they combine and react with CO3 ion to produce carbon dioxide and free electrons. These free electrons travels from external load to produce electricity, and this CO2 travels to positive electrode via bottom of the cell where it reacts with oxygen and produce CO3 ion. So at a cathode, the reaction taking place is O2 plus 2 CO2 plus 4 electrons gives twice CO3 minus ion. The overall reaction for typical molten carbonate fuel cell is H2 plus carbon monoxide plus oxygen gives H2O plus CO2. So this is how one molten carbonate fuel cell utilizes the chemical energy of fuel such as hydrocarbon and produces electricity by external load or external circuit. This is the largely used type of fossil fuel cell which utilize hydrogen as a fuel and molten carbonate as an electrolyte. For exam point of view, this particular cell is very important. Now let's see some of the advantages and disadvantages of this fuel cell. Well, one fuel cell converts chemical energy directly into electrical energy, and it eliminates the energy conversion in the form of mechanical energy. So it increases the efficiency. On a practical life, around 70% of efficiency with fuel cell is observed on ideal cases. So the first advantage of this fuel cell is that they are highly efficient. Around 70% of efficiency is being observed. Now the second advantage of this fuel cell is that they are flexible in nature, so that we can install or build a fuel cell near to its uses or its application. Not only that, they do not involve any bulky or large component, so that they can be easily transported from one place to another place. The next advantage of this fuel cell is that they do not involve any moving part like pumps and blower, which means that they require very little or no maintenance, while the other conventional plants required very high maintenance. The next advantage of this fuel cell is that they do not produce any kind of noise, and space requirement for such fuel cell is less compared to other conventional source of energy. Now, if pure hydrogen is used as a fuel, this fuel cell do not produce any kind of pollution. The only byproduct get from this fuel cell is water. So, they are non-polluting sources of energy. Well, the fuel cell do not involve any kind of condenser that eliminate the need of large and bulky cooling towers. Well, this fuel cell has only one disadvantage, and that is their high capital investment and their low service life. So these were the all advantages and disadvantages of fuel cell. Now let's see some of the terms associated with fuel cell. And first is the conversion efficiency of fuel cell. Since electricity generated by fuel cell is depend on what is called as free energy rather than heat energy. So to produce 1 mole of liquid water from hydrogen and oxygen gases is around 56.67 kilocalories at 25 degrees Celsius and atmospheric pressure. The heat energy for formation of liquid water is 68.26 kilocalories at 25 degrees Celsius and 1 atmosphere. Thus, if we find the conversion efficiency of fuel cell, that is around 83%. With ideal case, around 70% efficiency is observed. But in a practical case, typical hydrogen and oxygen fuel cell produces efficiency around 50 to 60%. This efficiency get reduced when the source of hydrogen is hydrocarbon and the source of oxygen is air. Slow reaction at the electrode also reduces the efficiency of typical fuel cell. The theoretical EMF of hydrogen-oxygen fuel cell is around 1.23 volts, while in actual life around 0.7 to 0.8 volt of EMF can be produced by the hydrogen-oxygen fuel cell at same condition. Now let's move to the next topic, and that is polarization of fuel cell. The difference between electrical output in ideal case and electrical output in actual case is known as the polarization. Since the actual fuel cell provides less of the electrical output compared to ideal case. Well, there are 3 different type of polarization. One is the active polarization, the next is resistance polarization, and lastly there is concentration polarization. So now let's understand what is the active polarization. Well, this is related to the activation energy barrier for electron transfer process on the electrode. During chemical reaction, the electrodes are emitted from the electrode, and this required the minimum amount of activation energy. But at low current density, this amount of activation energy is not enough. So this causes the loss in potential, and it is known as active polarization. This effect can be reduced by increasing the surface area or rising the temperature, or we can use catalyst to reduce this active polarization effect. Now let's move to the next polarization, and that is resistance polarization. Well, the internal resistance is the main reason behind this resistance polarization. This internal resistance is made up of 3 resistance: the electrode resistance, the bulk electrolyte resistance, and the interface contact resistance between the electrode and electrolyte. The loss due to internal resistance is the main reason behind this resistance polarization. Well, this effect can be reduced by using more concentrated electrolyte and closing the spaces between electrodes. Now let's move to the third type of polarization, and that is concentration polarization. Well, this concentration polarization is of two types. One is electrolyte side polarization and another one is gas side polarization. So let's see what is the electrolyte side concentration polarization. It is caused due to slow diffusion in the electrolyte that leads the change in concentration at electrolyte. Well, this can be reduced by stirring electrolyte or circulating electrolyte throughout the process. Now, next type of concentration polarization is gas side polarization. This type of polarization is mainly due to slow diffusion of reactant at reaction side and again slow diffusion of product from the reaction site. Well, this can be reduced by using small size of pores for the electrode. Now, let's see different type of electrodes. Well, there are two different type of electrodes. One is the porous type of electrode and another one is the non-porous type of electrodes. So, in porous type of electrodes, there are three different phases that need to be maintained. The gaseous fuel, the liquid electrolyte and lastly the solid electrodes. These three phases need to maintain their boundary throughout the process. Well, the dual porosity type of electrodes are used for this purpose. They maintain this boundary at the junction which is being made up of the core porous and the fine pores. Since the fine pore do not need to be conductor, hence we can use the plastic material for fine pores. Now let's see the second type of electrodes, and that is non-porous type of electrodes. Non-porous electrode such as ion exchange membrane are the classic example of these non-porous electrodes. Hydrogen diffusing through palladium alloy membrane allows the complete separation of gases at the membrane. This is the classic example of non-porous electrodes. This avoids the problem of interface control and direct chemical reaction at electrodes. Now let's see some of the application of these fuel cells. This fuel cell can be used for domestic purpose and it can be used for automotive purpose as well. By connecting this fuel cell in series and parallel assembly, we can generate reasonably high electricity that can be used for domestic and industrial purposes as well. Since these fuel cells are flexible so that they can move from one place to another place and they find their application in remote areas. Now, the last and the major application of this fuel cell is in the automotive industry. This fuel cell can be used to power up different vehicles and enhance the transportation system. So these were the all application of fuel cell, and this conclude the chapter of fuel cell. We will see you in a next video. Till then, keep watching, keep learning. Thank you.